Alright, this is iChem Lesson 2, Basic Atomic Structure. You will need a periodic table to follow along with this lesson, so go pause it, go pull out the periodic table I gave you in class if you don't have it. The internet is full of them, so pause the video, make sure you have a periodic table pulled up so you can follow along. Using the model of the hydrogen atom today in class, we highlighted the basic structure of the atom. We could kind of see that there's a nucleus, which is a dense positive core near the center of the atom. This contains the protons and the neutrons. And around the nucleus, there's an electron cloud. This is a much more sparse area with a negative charge, and this contains the electrons. So a dense core, a dense positive core, containing protons and neutrons, and a sparse electron cloud containing electrons. So the proton first. The proton has a positive charge like we talked about. It's used to identify the atom. So the number of protons is always the same for a specific element, and it thus is then equal to the atomic number. It's included in the calculation of the mass number. The change in protons is rare, but when it happens, it results in a total element change. The identity of the element is directly a result of the number of protons it has. The neutron, also in the nucleus with the proton, has no charge though, so think neutral, neutron, no charge. It has the same mass as a proton, so that the change in neutrons does affect the atomic mass. The protons plus the neutrons is equal to the atomic mass, but we'll talk about that more on the next slide. Electrons. Electrons are negative, like we talked about, so there's the core of protons, which is positive, and there's the cloud of electrons, which is negative. It gives the element its chemical properties. We'll talk much more about this through the rest of the unit. It's sometimes equal to the atomic number, but not always. And that idea is related to charge. We'll talk about that on the next slide. And it has nearly no mass, so just the protons and the neutrons are involved in the atomic mass. The change in electrons changes the charge and the stability of the element. So the important numbers. First is the atomic number. That is the main number above the element on the periodic table. It's always equal to the number of protons, and every element has a unique atomic number that's used to identify the atom. So example, lithium always has the atomic number of 3. The mass number, that's the atomic mass number. It's the usually not displayed on the periodic table. It's found by adding the number of protons and the number of neutrons together. You could also use this in the reverse. If you know the atomic number and you're looking for the number of neutrons, you can subtract the number of protons from the atomic number to get the number of neutrons. We'll do this more on the next slide. The atomic mass. This is the number displayed on the periodic table. It's calculated using relative abundance and mass of each isotope of the element. All that I just said, you're not expected to know yet, but just sort of keep it in mind. We're moving towards this in the next few days. All right, let's look at these examples. Example 1. How many protons, neutrons, and electrons are in the sodium atom above? First, protons, same as atomic number, always, always, always. So atomic number is 11, number of protons is 11. This is always true for sodium, 11 protons. Next we can look at the charge. The charge is plus There's no 1 here, but if there's no number, a 1 is implied, is plus 1. If it's positive, that means there are more protons than there are electrons. So there are 11 protons, so there should be 10 electrons. 1 less electron than proton results in a plus 1 charge. Last thing is our neutrons. Remember, protons plus neutrons equals mass number. So I can take the mass number, subtract the atomic number, 23 minus 11, that gives me 12 neutrons. All right, next example, example 2, write the isotopic notation for an atom with 50 protons, 69 neutrons, and 48 electrons. Isotopic notation, same thing as we see over here to the left. That's the isotopic notation for sodium, that particular sodium ion. Okay, so 50 protons. I use that to identify the atom. So I come over to my periodic table, I look for number 50, which is sort of in the bottom-ish right. It's tin, so I can go ahead and write SN for tin and fill in my 50 for my atomic number because my number of protons is always the same as my atomic number. Then I'm looking for my mass number next. I have 69 neutrons and 50 protons. I add them together to get 119. That's my mass number. The last bit is electrons. I have 50 protons and 48 electrons. That's more protons than electrons by 2. So it's 2 plus. Remember, more protons is positive. Finally, example 3, isotopic notation for atom with 16 protons, 16 neutrons, and 18 electrons. I need to go to my periodic table again and look for number 16. It's up in the top right, and it is sulfur. So I put the S for sulfur. I can immediately fill in the 16. Then for my mass number, I'm doing protons plus neutrons. 16 plus 16 is 32. And then I notice I have 18 electrons and 16 protons. That's 2 more electrons than protons, so it will be -2 charge. All right, so don't forget to go and fill out the viewing guide and make sure you, if you need to review this, go back and look at some of them. Make sure you have these examples down before class tomorrow.